So we're going to continue on with our discussion of operators in the Flux class, which you'll need to understand in order to do forthcoming assignments. And we're going to start by focusing on the first set of transforming operators. And this will be map and mapNonNull. And as I'm sure you recall, transforming operators take the values and or the types that come to them from earlier parts of the Flux stream and will do something to them. They'll transform them in some way. So we'll start first by talking about the map operator, which transforms the items that are emitted by the flux. You've seen something like this before. And so what map does is it takes a function that's a mapper function, and it applies that mapper function synchronously to transform each item in the stream that it's working on. And of course, this is a functional interface that takes a value as a parameter and returns a return result, which could be of different type or different value than what was passed as the parameter. If the mapper function throws an exception, then map can terminate. Let's assume, for sake of argument, it doesn't throw an exception. If it doesn't throw an exception, what it does is it returns a flux that has been transformed by the mapper. So all the elements that come in will have been transformed in one way or another. A couple things to remember about map that are very important. First, the number of output items that is going to come out of map must match the number of input items that went into map. So here we can see we take a big fraction list, turn it into a flux, and then for each item there, we multiply each item in the flux stream by some constant or whatever, and we'll end up with a stream that has new values. Remember, you can also change the type if you want, not just the value. You don't have to change the type, but you can. And that's why in the marble diagram you see here, the shapes of each of these different elements has been switched from circle to square, just to indicate something's changed with respect to the types. RxJava has a map operator that works exactly the same way. Surprise, surprise. No surprise, really. And interestingly enough, Java Streams has a map operator that works very similarly as well. So here's an example where we have a list of 3 lowercase strings, which we turn into a stream, and then we call 2 uppercase on each of these strings, and then we collect the results into a list. So this is an example of doing something similar with Java Streams. Pretty clearly a very common functional programming feature. There's also another operator called mapNonNull. And it actually turns out to be very useful, and we'll probably get a chance to play around with it in parts of this assignment or upcoming assignments. And this is used, again, to transform the item that's emitted by the flux. It uses a mapper function like before. However, one of the things to keep in mind here is it's possible for a mapper function to produce null values. That's possible. You're not really supposed to do it, but it's possible for it to happen. And what's interesting is that if you have the mapper function return a null value, mapNonNull will not emit those values. So what it's doing is it's mapping things, but it's omitting. It should have really been map omitting not null or something, but that would have been a bit too verbose. So null values are actually not emitted by mapNonNull. And basically, it kind of behaves like map followed by filter, where you filter out nulls. However, you can't do that in Project Reactor. There's no way to filter out null values. They're just not allowed. You're not supposed to have them. So as a result, you can't do this. You can't have map followed by filter. So the only way to do this type of behavior is to use mapNonNull. So it's working around kind of a quirk in the semantics of elements that can be in streams in Project Reactor. As with mapNonNull can terminate if the mapper throws an exception. And it returns a transformed flux that will not emit any nulls by design. So let's take a look at a very simple example that will illustrate this. So here we're going to use Flux just, which is that factory method we talked about the other day. And that's going to create a flux stream of 2 big fractions, one of which is going to be 100 over 3, and the other which is going to be 100 over 10, which will be reduced to 10. And what we're going to do here, and I wouldn't recommend writing code like this, this is just for the illustration purposes, we're going to take the big fraction that comes through here, And if the big fraction equals 10, we're going to emit a null, or try to emit a null. Otherwise, we're just going to omit the big fraction. So, of course, what mapNonNull will do is it will just ignore the value that was 10 because it turned it into a null. Once again, don't write code like this. This is just to illustrate the concept of mapNonNull. As with mapNonNull can transform the type and the value of the elements it processes. And it's probably worth noting, although I don't really note it here, that mapNonNull could in fact return fewer elements than it received because it's going to get rid of anything that would have been null. RxJava does not have a mapNonNull, which is actually very annoying. And there's several ways you can work around this. One way is to use a Java optional, which works, but my goodness, it's an awful lot of extra ceremony to work around the fact that there is no mapNonNull in RxJava. Something else you can use is use something called transformers, which have nothing to do with large language model transformers. It's just basically a way to write your own custom operator. In this case, we call it mapNonNull. And it's going to have the logic in order to deal with nulls without actually trying to emit nulls. And then we can use another method called compose, which is an operator that can be used to allow custom operators to be implemented in RxJava. So we can add our mapNonNull mechanism and use it properly. Again, this is an RxJava quirk. I wouldn't worry too much about it since we're not really using RxJava in this class, just in case you ever get stuck having to do it. So that's the end of the discussion of the key transforming operators in the Flux class.